Hello friends, welcome to Catalyst Chemistry YouTube channel. As we discussed in last class, most important point about what SN1 and next one is what SN2 reaction. Okay, you know very well about that in SN1 reaction the most important point we are going to consider methyl bromide can react with what. If you want you can take methyl chloride also. Methyl chloride or a methyl bromide you have to take that can react with what KOH. That KOH must and should we have to maintain that is aqueous. In the presence of it there is a formation of product is what methanol plus release of what KBr. This is the what reaction. After that we are going to write that is mechanism for what SN1 reaction. In that case there is a formation of what transition state. There is a formation of what transition state. Next after that what there is a what simultaneously means what at a time the bond making and bond breaking takes place. Just here in this case OH is there, in this case Br is there, the OH is going to attack on carbon, the Br will go out. This process takes place at a time or simultaneously in SN2 mechanism. Finally there is a formation of product is what that is a methanol. Okay, this is the what mechanism. Next after that important point is what the important point in this case is what that is reactivity. Reactivity means what CS3 is a more reactive than primary, next one is secondary, next one is what tertiary. You can say 1 degree, 2 degree, next one is what 3 degree also. Next most important mechanism is what SN1 mechanism. S means what substitution, N means what nucleophilic, 1 is indicate what unimolecular reaction. Okay, in this case this is SN2 is having a one step reaction, but SN1 is having a two step reaction. In this case we are going to consider tertiary because tertiary is a more reactive towards SN1 mechanism. In this case we are going to consider tertiary butyl bromide. Okay, if you want you can consider tertiary butyl chloride also, no problem, that can react with the aqueous. That aqueous is what means what KOH is aqueous. Don't use alcoholic. In the presence of it there is a formation of product is tertiary butyl alcohol. Okay, this is what reaction. Next after that step 1 means what formation of carbocation. Step 2 means what attack of nucleophile on carbocation. That carbocation is a planar in structure. Bear in mind that point is also important. In one time they asked in entrance exam what is the hybridization of planar. Where there is a planar is there, it may be a trigonal planar, normal planar is there, the 100% hybridization is a sp2, the bond angle is 120 degree. Bear in mind, important. Okay, this point they are going to ask you. Okay, compulsory, that is having a sp2. Formation of carbocation, where there is a formation of carbocation is there, no, that is tertiary carbocation. Tertiary carbocation is a more stable. Why it is a more stable means with due to hyperconjugation. In this case what CH3 is there, totally 9 hyperconjugations are there. What is hyperconjugation, what is carbocation, all those things you have studied in +1 level. Okay. Next after that second step means what, if the planar carbocation is there, the nucleophile is going to attack front side means as well as back side also possible, but in this case the particular if you are going to consider there is attack what front side attack, back side is not possible. Why it is a back side is not possible in a original position? Because of what steric hindrance. The most important word in chemistry, that is what steric hindrance. Okay, bear in mind, steric hindrance means what, you know very well about that. CH3 is there, no, these three groups are bulkier group. Bulkier means what, larger group. If the incoming nucleophile is not going to attack on the back side, because of these three groups are opposed to what incoming nucleophile, that's why the nucleophile is going to attack in a front side. Okay, that point is most important. Okay, next today in this class we are going to discuss the continue part of what that SN1 reaction only. In this case we are going to consider some of the note. Note means you know very well about that SN1 mechanism, the tertiary is more reactive than secondary, after that primary, after that what important point is what CS3. CS3 is usually very less possibilities there in a what SN1, but important thing is what in this case tertiary. Tertiary means what, that is 3 degree. In this case important point, one point is there, that is called what allylic benzene. We are going to consider what allylic chloride. If allylic is there, benzylic is there, that point important. Okay, that point we are going to study in this class. The first important point is what note is there. Okay, I have taken it as a note, otherwise if you want you can take a golden point also, no problem. Even though allylic is there, next one is what benzylic halides or primary halides. You know very well about that allylic and benzylic halide. What is allylic, what is benzylic, already we have studied, okay, in this topic only starting, okay. Just here allylic one point is there, next one is what benzylic is there, halides are primary halides. Primary halides means what? The halogen atom attached to the carbon, that carbon containing must and should two hydrogen atom, that is what primary. Otherwise that carbon containing one substituent group means what, in this case what, only one benzene, or that is indicate what, primary. Okay, otherwise better you have to remember with the help of the hydrogen is a better understanding. Okay, next after primary they undergo substitution preferably by SN1 mechanism. Just see here, in SN1 mechanism the reactivity actually tertiary is there, but SN2 mechanism the reactivity what, CS3 will come first, no, after that primary will come first, but this in this case order is different. Okay, that is why this one I have taken in a note. Just here, if the primary halides is there, in that what, allylic, benzylic particularly, bear in mind these two having a different property. That is why in this case what is the substitution preferably by what, SN1 mechanism. Okay. Why allylic and benzylic can undergo SN1 mechanism, that point we are going to study. Okay. Just here, this is CH2 double bond CH, next one is what, CH2 Cl is there. Okay, what is the name of this one? Allylic, you have to take, this one is allylic chloride. Okay, this one is allylic chloride. Why it is allylic chloride? Very simple definition I told. This halogen atom attached to a saturated carbon atom next carbon double bond, that is called allylic halides. Okay, this allylic halide is there. One more example is what, this is a benzylic halide, or benzyl chloride is there, this allyl chloride, better you have to take, no problem. Particularly if you are going to take a removal of this chlorine, that time this is act as a allylic carbocation. Okay. Now allyl chloride is next one is what, this is a benzyl chloride is there, this is what, allyl chloride is there. Okay, no problem. Just here in this case benzyl chloride, the halogen atom attached to a saturated carbon atom, next one is aromatic ring, this one is act as a what, aromatic ring, this is, that is indicate what, benzyl chloride. Okay. Just here, in this case why this can undergo SN1, next why this also undergo SN1, question. Okay. Just here, most important point is what, in this case, resonance. Resonance is the most important point. Resonance structure of what, allyl carbocation, otherwise you have to write allylic carbocation, no problem. Okay. CH2 double bond CH is there, next one is what, CH2 plus charge is there. Okay, that is what most important, bear in mind. Okay. Next allyl carbocation is there, allyl carbocation. Okay, what is the, this is the what, resonance structure. Just here CH2 double bond CH, next one is what, CH2, this is going to get a positive charge. This one is indicate what, primary carbocation. Why you are going to call it as a primary carbocation? Because this carbon containing two hydrogen, positive charge is there, that is why carbocation. Carbocation means what, positive charge. Carbanion is there, that is what, negative charge. Okay. Just here, first I am going to write a resonance structure. This arrow mark, this double headed arrow mark is there, no, this look like, okay, like this. This is a resonance arrow mark, bear in mind, this is what, resonance arrow mark is there. Okay. That is why in this case resonance takes place, that is why I am going to write what is the next product. Just here, in this case what, if positive charge is there means that is understood the loss of an electron. In this case just I am going to satisfy the electron, means what, in this case resonance takes place, double bond is there, no, this double bond can donate here. Okay. If double bond can donate here, automatically in this case what, satisfy the electron or satisfy the bond also. Okay. That is why there is a formation of product is CH2. Okay. In this case what happened, this double bond shifted here, automatically this carbon is going to get a positive charge because of what, loss of an electron. That is why in this case CH2 positive charge single bond, this is CH double bond CH2. Okay, this one is indicate what, CH2. Okay, final product. Okay, in this case what happened, this one is indicate what, resonance. If you are going to write this double bond, if you are going to shift this double bond in this case means automatically we are going to get this one. That is why in this case what, only one resonance is possible. In this case only one resonance is possible. Why allylic chloride or allyl chloride more towards SN1 mechanism? Because of this carbocation is a more stable. Why this carbocation is a more stable? Because of the reason is resonance. If resonance takes place, that is what, more stable. I will tell you very most important point, more number of resonance, more stable in organic chemistry. Particularly bear in mind, that is a fixed point, this one is okay. More resonance structure, more stable, okay. That is why in this case resonance takes place, that is why this is the most important point. If you are going to consider tertiary butyl bromide is there, no, what is the starting material for SN1 mechanism? Tertiary butyl bromide. You have to compare with tertiary butyl bromide and this one, means automatically this one can most important, this can undergo what is that, SN1 mechanism. First point is clear, okay. The next is what, resonance structure of what, benzyl carbocation or benzylic carbocation, okay. This is the what, benzyl chloride is there, this one is indicate what, benzylic carbocation or a benzyl carbocation. Positive charge is there, no, carbocation. Just here in this case what, resonance takes place. How resonance takes place? Just here I am going to write this one is there, indicate what, resonance mark, okay. Just here I am going to shift this double bond towards here, okay. Don't, in this case possible, no possible, because already carbon carbon single bond is there, it is not possible to rotate this one. That is why I am going to take this double bond, I am going to rotate here. Automatically in this case what happen, the carbon carbon double bond is possible, okay. Next one is important thing, in this case we are going to get a what, positive charge, no. In this case means what, if there is a shift of this bond, automatically in this case we are going to get a positive charge. I am going to write a product here, this is what, product, benzene ring, double bond, in this case what happened, double bond, this is CH2. Don't write here positive charge, because of already it is a satisfy the bond. 2 hydrogen is there, 2 bond is there, carbon is a valency of carbon 4, it can bond, it can form the only 4 bonds. Automatically in this case we are going to get a positive charge here, okay. Next, after that the next step possible is there. In this case what happen, this bond is going to donate here, satisfy this positive charge. Automatically in this case we are going to get a positive charge. That is why there is a formation of product is just here, okay. In this case what happened, double bond formation, here is double bond, here double bond, CH2 as it is, okay, no problem. In this case there is a formation of what, positive charge, okay, clear. Next, the next step, just here I am going to rotate the here, okay, this double bond is there, I am going to rotate here, there is a formation of what, double bond. This one is indicate what, resonance. Next one is what, in this case double bond, here double bond is there, this is what, CH2, okay. Next in this case I am going to get a positive charge, okay. 1, 2, 3, 4, totally 5 resonance are possible. The last resonance just here, in this case what happened, here double bond is there, next one is what, in this case what, positive charge, electron deficient is there, better you have to donate here like this, okay. It can donate here, there is a formation of product is what, final product, this is what, double bond, next this is double bond, here double bond, next in this case what happened, CH2 positive charge, in this case what, CH2 positive charge. This is indicate what, resonance structure. Finally we are going to get a what, same product, no. This first product and last product both are what, same. In this case what happened, the mechanism, this mechanism is what, or totally how many resonance possible, 1, 2, 3, 4, 5 resonance are possible. That is why the benzylic carbocation is a more stable. In this case what happened, the 5 resonance structures are possible. I told the important point, if the more resonance structure, more stable, okay. That is why I quoted in a box, okay, important. Higher the stability of carbocation, higher is the reactivity of the compound by SN1 mechanism. This is a fixed point. Higher the stability of carbocation, most important point. stability, this is a more stable, more resonance structure, more stable, this is a basic point. That is why in this case higher the stability of carbocation, higher is the reactivity of the compound towards the SN1 mechanism. Okay, this is what important. Okay, next after that in this case you know very well about that stability of the carbocation is directly proportional to reactivity of alkyl halides or alkyl carbocation, no problem we can say. Okay, important point is what the carbocation means stability is directly proportional to carbocation. Next I am going to consider most important example, that is called what, if the more number of phenyl groups attached, that is called what, more stable. Just see here, I am going to take an example here, I am going to write this is benzylic is there. Okay, just I am going to consider this is indicate what, CH2Cl is there, only one benzene ring is there, no problem. Next I am going to consider two benzene ring, I am going to remove one hydrogen. Okay, just here the next structure is like this carbon going to get one hydrogen. Next after that in this case there is a formation of what, benzene ring, here one Cl is there. Okay, next one I think it is a visible, otherwise I am going to write here only. Okay, okay, I am going to write here only, just see here. Next I am going to write benzene ring is there. Next after that this carbon, one hydrogen is there, benzene ring. Next in this case what, benzene ring, just here I think it is visible. Okay, 1 2 3, in this case 3 benzene ring, in this case 2 benzene ring, next in this case what, 1 benzene ring. Sometime they are going to ask you out of these three which is a more stable towards a SN1 mechanism, they are going to ask you, now tell me which is a more stable. In this case the right answer is what, this is a more stable compared to this one. Next second most stable is this one, third most stable is what, this one. That is why in this case important point, stability for carbocation, this is the most stable. Next after that what, this one, this is the order. More number of phenyl group, we can say what, phenyl group, more number of phenyl group, that is more stable. Why like this? Again question arises in this case, why this is having a what, 3 benzene ring or 3 phenyl ring having a what, more stable towards a SN1 mechanism. Just here I am going to remove this hydrogen, there is a formation of what, carbocation, this is a tertiary carbocation, no, tertiary carbocation is a more towards a what, SN1 mechanism. Just here in this case I am going to shift here bond. Okay, in this case what, the resonance takes place. In this case how many resonance are possible? Obviously the answer is what, 5 resonance are possible, no. In this case 5, in this case what, in this case also 5, like this. Okay, you can say what, hyperconjugation also, no problem. Okay, in this case what happened, that is why in this case more resonance structures are possible, more stable. This is more resonance structures are possible, that is why this is a more stable compared to what, this one. That is why in this case this is the highest stability order towards a SN1 mechanism. Okay, this is the most important point. Okay, make it perfect, bear in mind this point. Okay, in this case the important point is what, they are going to ask you allylic and next one is what, benzylic in a position. Okay, that is why you have to practice, otherwise in examination they are not going to ask you, but board examination sometimes they are going to ask 1 mark also, that is why make it perfect. Okay, okay, fine. Next one is there, that is called what, stereochemical aspect of SN1 mechanism. Okay, that point we will study next video. Thank you.